moving on. Now this question asks us what is the slope of the curve y equals x over x plus 1. So let's write down the question number. So our function is y, or let's say f of x equals to x over x plus 1, which is the same as y equals x plus x1. I'm just using another notation right over here. Oopsie, what happened? Nice. And you're asking for the slope of the curve at a point. So in order to find the slope, we would differentiate our function right over here. And how would we, and since our function f of x is like a division with two other functions, so let's just use the division rule, or I guess the quotient rule. That's what it's called. So let's just use the quotient rule. Use quotient rule for calculus. Use the quotient rule in calculus. So let's just use the quotient rule, or I guess more like functions, or I guess it can be called calculus. Okay, so it's basically the quotient rule. It basically states that the lower term multiplies the derivative of the upper term. So dy over, or I guess d over dx. So the d over dx of x minus the top term times derivative of the bottom term, which is x plus 1, the derivative of x plus 1, divide this entire thing divided by x plus 1, or the bottom term squared. So this is our how we apply the quotient rule. You basically just have the formula and you plug the top and bottom term into the formula, and you just memorize the formula in order to like solve this problem. There was like a little song that goes low d high minus high d low over low squared. And there's like a couple of different rhymes that can help you to memorize this formula more easily. But the one that I use is just basically low, meaning the lower term, d high, derivative of the top term. Low d high minus high, the upper term, minus high d low, the upper term, minus the upper term times the derivative of the bottom term over low squared, which is the bottom term squared. So yeah, that's how we solve this problem. And now let's further our simplifications. So the derivative of we just write down our bottom term first. And in order to find the derivative of x, it's just 1. So you just use your derivative rule of polynomials. And high, which is our x, times the derivative of x plus 1, which again is just 1, over low squared, which is x plus 1 squared. So we actually have x plus 1 minus x over x plus 1 squared. So our derivative of the function is just 1 over x plus 1 squared. And this is our derivative of the function. Now, we just need to plug in the x values to find the slope of the function at this point. So we don't even need to know the y values, but it was given to us anyways. So let's do f prime of x, which is 4 in this case over here. So we have f prime of 4 equals to 1 over 4. You plug 4 into x because it's f prime of x. It's the slope. So you plug 4 into x, and we have 4 plus 1 squared on the bottom. So the slope in this case is just 1 over 25, which is equal to 0.04. Nice, and this is our slope. So our slope, oopsie, I don't want to spell slope wrong. The slope, or the gradient, it's just 1 over 25, or 0.04 if you prefer decimals. Alright, so this is our solution over here. And now, let me see the sample solution. Yes, they actually wrote down the formula for the quotient rule, but you just plug in what we have for the top and the bottom term in the function, the original function, and they did their thing, which is correct. And then let's look at their calculated results. It's not 1, so there's something that they did wrong. They substituted everything up to this point is correct, but they're trying to find the curve at the point 0.0 and 0.4, but we were asked for the point 0.4 and 0.4, and the point 0.4 is not even on the function, because when the function is at 0, when the x is at 0, the y coordinates is also at 0, so this function doesn't even go through 0 and 0.4. Ah well, so I guess I'll just say something like the sample solution is incorrect. The question asked for the slope at x equals 4, not x equals 0. Correct result is 0.04 or 1/25. It's 1/25. Okay, and let's just say the solution is incorrect over here.